In this video, we're going to multiply and divide radicals. At the top of your paper, there are a few notes we need to fill in. Radicals can be multiplied by radicals, but they must be simplified if possible. If there is a number on the outside of the radical, that number is called a coefficient. A coefficient can only be multiplied with the coefficient. A radical can only be multiplied by a radical. Example 1, -2 times your radical 6. We're going to multiply that by 7 radical 10. So I'm going to draw some curved lines, and I'm going to pair the coefficient with the coefficient and the radical with the radical. So I'm going to take -2 and multiply it by 7. Under my radical, I have a square root of 6 and 10. So I have -14 times that radical 60. I'm going to break down the number under the radical, the numbers under the radical. I'm going to use 15 and 4 for 60. Take the square root of 4, so -14 times 2. I'm going to leave the 15 under the radical. 15 under the radical is a combination of prime numbers, which are 5 and 3. Multiply the numbers on the outside. -28 times the radical, or the square root of 15, would be your final answer. For example 2, this is a different scenario or another way to write the problem. 6 radical 3 times 2 radical 6. Both of those are in parentheses. I'm going to still draw curved line from the coefficient to the coefficient and the radical to the radical. So 6 times 2 is 12. And under the radical, I have 18. I'm going to simplify again, multiply the radicals into the radicals, but I have to simplify them. My two factors of 18 I'm using are 9 and 2. I'm going to take the square root of 9, so I bring a 3 on the outside. 9 is a perfect square. The final step will be to multiply the numbers on the outside. 12 times 3 is 36, and then I just bring down that radical of 2. Example 3, I have 2 radical 5 squared. What that means is that I have 2 radical 5 times 2 radical 5. I simply rewrite the problem so that I know that I have 2 of them, or I'm multiplying what I'm given by itself. When I do that, I'm going to draw my curved lines again. So 2 times 2 is 4. I can multiply the coefficients, or the numbers on the outside. Under the radical, 5 times 5 gives me 25. You should notice 25 is a perfect square. And when we take the square root of 25, we're left with 5. For the final answer, I multiply 4 times 5. That's all I have left. And that gives me an answer of 20. In this next lesson, we're going to multiply conjugates. This is at the bottom of your paper. A conjugate is a binomial where the second term is the opposite of the first binomial. So just for example, here on the bottom, I'm going to write 1 plus the square root of 2. In order to get the conjugate term, it is the opposite. So 1 minus the square root of 2. What's important about both of these is the term in the middle. So the conjugate has the opposite sign in the second term. For example, when we're looking at number 1, we take the square root of 5. We put a minus sign and a plus 1. In the first term, there's a plus 1. In the second term, because we're multiplying by the conjugate, we have to put a minus sign in the middle. So when you multiply this, you're going to FOIL it. FOIL, first, outer, inner, last. So the first terms, square root of 5 times square root of 5 is the square root of 25. So those are your first terms. Your outer terms, square root of 5 times a negative 1. So that's a negative square root of 5. Your inner terms, 1 and square root of 5. So that gives a positive square root of 5. And then finally, your last terms are 1 and negative 1. So that gives a negative 1. I wrote these in 4 different colors so that you can see how I am multiplying my numbers. Again, it's just like I'm using FOIL, but you have radicals. In the next step, I can cancel the center terms because negative square root of 5 plus square root of 5 is going to cancel and it's going to be 0. Next, square root of 25 is 5. I break down that negative 1. Your final answer for example 1 is only 4. I'm going to do that again. So I have to write the conjugate. I'm given square root of 2 minus 3. The conjugate term is going to be square root of 2 plus 3. Again, all I do is simply change that second term. First, square root of 2 times square root of 2 is square root of 4. The outer terms, square root of 2 times 3 is a positive 3 times the square root of 2. Those inner terms is a negative 3 square root of 2. And then finally, those last terms, negative 3 times 3 is a negative 9. Just as before, those middle terms are going to cancel because 3 square root of 2 minus 3 square root of 2, minus 3 square root of 2 is going to give me a 0. So I have square root of 4 minus 9. 4 is a perfect square. Square root of 4 is 2. And 2 minus 9 is going to give you a negative 7 for your final answer. The next page, your notes are dividing radicals. So radicals can be divided, but radicals cannot be left in the denominator. So your final answer cannot have a radical in the denominator. If a radical is in the denominator, you must rationalize the denominator, multiply 1, which is the bottom radical over itself. So I'm going to show you how to do that as well. Example 1 for dividing radicals. This is a really good problem. On the top you have a radical, on the bottom you have a radical. 98 is an even number and 98 is divisible by 2. It evenly divides. So if I take the radical of 98 and divide it by the radical of 2, I'm going to have the radical 49. When I take the square root of 49, your answer for number 1 is simply 7. For example 2, 16 divided by that radical 2. First thing you should notice that there is not a radical in that top number. Because there's not a radical there, I have to rationalize this denominator because there's only a radical in the denominator. I do that by multiplying by 1. When you multiply by 1, you take the bottom radical and put it over itself. So square root of 2 over square root of 2 will equal 1. Now that I've done that, I simply multiply across. So 16 times radical 2 is 16 radical 2. That's the numerator. In the denominator, radical 2 times radical 2 is a radical 4. Now I can start simplifying. So 16 radical 2 over 2. It's over 2 because the square root of 4 is 2. There's one final step to this, and that's going to be to simplify. I have 16 radical 2 over 2. 16 is divisible by 2, so your final answer for this second problem is going to be 8 square root of 2, or 8 radical 2. For example 3, I have the square root of 7/8. Now, when you see this written like this, it can always be separated, always. It can be rewritten as square root of 7 over the square root of 8. There's a radical in the denominator, so I'm going to multiply the top and the bottom by the radical 8. Once I do that, I multiply across the numerators first and then the denominator. 7 times 8 is going to give you 56, so you have the square root of 56 on the top. On the bottom, you have the square root of 64. In the top, I need two numbers that multiply to give me that 56. One of them being a perfect square, so we're going to use 4 and 14. Square root of 64 is 8. In the next step, I'm going to take the square root of 4. So that's 2 square root of 14 over 8. That's not my final answer because you should notice 2 and 8 have to be simplified. So the final answer to example 3 is square root of 14 over 4. Example 4. 4 divided by that radical 8. I have to rationalize that denominator because that's the 8 on the bottom. There's a radical on the bottom. Multiply across. So 4 times the square root of 8 over that square root of 64. The top has to be simplified as well as the bottom radical. So on the top, I wrote out 4 and 2 because they're the factors of 8. And on the bottom, I have that radical 8. Once you take the square root of 4, on the outside, you have 4 times 2, a radical 2, and then bring your 8 on the bottom. When you multiply 4 times 2, you're left with 8 radical 2 over 8. Remember, we have to simplify. 8 divided by 8 simply equals 1. The final answer is radical 2. Number 5, I have the radical 36 over 25. As I told you before, you can rewrite this as your radical 36 over the radical 25. And now I can just simply take the square root of both of these numbers. You should notice that 36 and 25 are both perfect squares. The square root of 36 is 6. The square root of 25 is 5. 6 and 5 are in their lowest terms. That is your final answer. Please remember, please remember, all of your answers will be in simplest fraction or radical form. You cannot have any decimals. The last example, which is example 6, I do not have to rationalize the denominator because there is not a radical in the denominator. However, I have to simplify that radical 48 that's on the top. My numbers for that radical 48 are 16 and 3. Once you take the square root of 16, you get 4, and it comes on the outside. You leave your 3 under the radical, and then you bring down your other 3, which was in the denominator. 4 radical 3 over 3. is your final answer because 4 and 3 do not have any common factors.